Hello.
Good evening, sir.
Good evening, ma'am. Good evening, ma'am. Let's start.
Just
Okay, ma'am. Take time. No problem. Hello, ma'am. Hello. Hello. Can you hear me? Dhanalakshmi, can you hear me? இல்ல பாருங்க. Yeah. Can you hear me? Dhanalakshmi, can you hear me? Hello. Ma'am, can you hear me? Ma'am, can you hear me? Hello? Can you hear me? Ma'am, can you hear me? Now can you hear me? Now? Now can you hear me? Okay. Ma'am, make me a host. Can you hear me now?
Yes, sir, I can hear.
Okay, ma'am. Okay. Thank you, ma'am. I don't know what was the issue that time. All right. So we'll continue with some of the questions what we were learning from last class. Now, this reaction, phenol, chloroform, and sodium hydroxide. So remember, a named reaction, Riemer-Tiemann reaction. Reactions. One is the reaction between phenol, chloroform, and sodium hydroxide. So when phenol, chloroform, and sodium, the product what we get is salicyl aldehyde. The product what we get is salicyl aldehyde. So the second reaction is phenol, carbon tetrachloride, CCl4, and NaOH. So the product what we get is salicylic acid. The product what we get is salicylic acid. Now here the question is phenol, chloroform, and sodium hydroxide. Therefore, you get a sodium salt of salicylaldehyde. On acidification, we get salicylaldehyde. Now the question, the electrophile involved in the above reaction. Electrophile. Now, the CHCl3 chloroform in the presence of a base like NaOH or KOH, right? NaOH or KOH. Here it's NaOH. It will give a carbon atom with Cl like this. This is an intermediate compound. This bond will shift here and gets eliminated as Cl minus. This Cl minus will react with Na and get eliminated as NaCl. Now what we have is, we have carbon, 2 chlorine atom. This carbon, 2 two chlorine atom along with this bond. That bond consists of two electrons. This is the electrophile involved in case of Riemann-Tiemann reaction. This is called as dichlorocarbene. This is called as carbenes. So carbene is an electrophile here. Therefore, the answer for this question is option 2. The next question. Which of the following reagents may be used to distinguish between phenol and benzoic acid? Now, phenol is this, and benzoic acid is C6H5COOH. Now, which of the following reagent may be used to distinguish between phenol and benzoic acid? Both have acidic character. Now, phenol, when treated with neutral ferric chloride, we get a pink color or a pink color solution. The color changes to pink. But when benzoic acid is allowed to react with neutral ferric chloride, no color change. No color change. So, to differentiate between phenol and benzoic acid, the reagent which is used is neutral ferric chloride. The answer for this question is option 4. Maybe you would have done the salt analysis, not the salt, the compound analysis. Organic compound analysis is not there for you in 12th standard. In the laboratory, we distinguish between phenol and benzoic acid by the test called as neutral ferric chloride test. Both belong to the same group. Now, carbolic acid is a name used for opium, phenol, chloroform, carbonic acid. So the simplest phenol, that is C6H5OH, this phenol is also called as carbolic acid. So phenols are called as carbolic acid. The answer for this question is option 2, phenol. The next question, are you following? Are you following? The next question, in a reaction, phenol in the presence of zinc, we get a product A. This product A with concentrated nitric acid, sulfuric acid, 60 degrees, we get product B. And this product B, when treated with the zinc, we get a product C, that is NaOH, in the presence of NaOH, the compound AbCr. The compound is AbCr. Now, phenol, when heated with zinc dust, this reaction we have learned in the regular class. When this phenol is heated with zinc dust, zinc and oxygen gets eliminated as zinc oxide, forming benzene. The product formed is benzene. This is A. This benzene, when treated with nitrating mixture is mixture of nitric acid and sulfuric acid. So what happens if I represent a hydrogen atom here, I can write nitric acid like this. So H and OH gets eliminated as water. In place of H, NO2 goes. Therefore, we get nitrobenzene. This nitrobenzene this is B. This nitrobenzene on reduction with zinc and NaOH. This on reduction with zinc and NaOH. That is, you need 10 moles of nascent hydrogen, reduction 10 moles of nascent hydrogen. So the product formed is a benzene ring. We'll represent it this way. This will undergo reduction to form NH group. And another benzene molecule like this. This also will have NH group here. These two will get bonded. This is called as hydrozobenzene. This is called as hydrozobenzene. Azo means nitrogen. So we have two nitrogen containing compounds. Therefore, it's called as hydrozobenzene. So hence the answer for this question is option 4. Benzene is A, nitrobenzene is B, and hydrozobenzene is C. Therefore, the option is 4. Next question, 13th one. Phenol on oxidation gives chloranil. The oxidant used is. Now the phenol This is phenol. When this phenol is heated with potassium chloride, KClO3, in the presence of HCl, we get a product like this. We have learned something called as benzoquinone. If you remember, this is benzoquinone. Now, we are not talking about benzoquinone, we're talking about chloride by chlorine. This will be the structure of chlorine, which brings about oxidation of phenol to give chloranil is potassium chlorate and HCl. So this chloranil is used as a fungicide. It is a fungicide. It is used as a seed protectant. Seed protectant. Hence, the answer for this question is option C, potassium chlorate and HCl. Oh, sorry. The next one, a characteristic group test for phenol. Lieberman's nitroso test. We have learned Lieberman's reaction, coupling reaction, benzene diazonium chloride, and also phenol is tested by using ferric chloride. You get a pink color, I told you. So the characteristic test for phenol is it's all the three. Therefore, the answer for this question is option 4, all the above. Phenol can be converted into salicylic acid by Itard's reaction, Kolbe's reaction, phenol with carbon tetrachloride in basic medium, both 2 and 3. So Kolbe's reaction and Riemer-Tiemann reaction. See, Riemer-Tiemann reaction is this. Riemer-Tiemann reaction. There is phenol, chloroform, carbon tetrachloride and the base, sodium hydroxide, gives salicylic acid. Likewise, the Kolbe's reaction. The Kolbe's reaction, it is phenol, sodium hydroxide, and carbon dioxide gas. So this also gives salicylic acid. Hence, the answer for this question is both option 2 and 3. Kolbe's reaction and Riemer-Tiemann reaction. We can prepare salicylic acid. The 16th question. Resorcinol and concentrated sulfuric acid in the presence of phthalic anhydride produces a compound which is a dye, an antiseptic, an indicator, a detergent. So resorcinol is an example for dihydric phenol. We have learned the classification of phenols based on the number of OH group present. This is resorcinol. Now, this is benzene. This is benzoic acid. And if we have one more acid group here, it is called as phthalic acid. This is called as phthalic acid, PTHALIC, phthalic acid. Now, when we say phthalic anhydride, what happens is this H and this OH gets eliminated. So water. When they get eliminated as water, we have a benzene ring. We have C double bond O. You have this oxygen, we write it like this. And here we have C double bond O. This is the structure of phthalic anhydride. This is the structure of phthalic anhydride. So this is resorcinol when it's allowed to react with phthalic anhydride. A benzene ring, C double bond O, C double bond O, and oxygen, phthalic anhydride in the presence of concentrated sulfuric acid. So we get a molecule called as fluorocene. Fluorocene. Fluorocene, fluorocene. This fluorocene is a dye. It's a coloring agent. It is pink in basic. This fluorocene gives pink in basic medium and colorless. It becomes colorless in acid medium. Acid medium. Therefore, the product formed here is resorcinol reacts with sulfuric acid and phthalic anhydride to form a dye called as fluorocene, which gives pink color in basic medium, and which becomes colorless in acid medium. The next question. Phenol is weakly acidic, but does not react with sodium bicarbonate like carboxylic acid. Hence, phenol is weaker than carbonic acid. Phenol is stronger than carbonic acid. Phenol is stronger than carboxylic acid. None of the above. Carbonic acid is soda water. Carbonic acid is H2CO3. Now, carboxylic acid, if I take any carboxylic acid, CH3COOH, when this carboxylic acid is allowed to react with sodium bicarbonate, so what happens is sodium acetate will be formed, CH3CONA. Water will be formed with the liberation of carbon dioxide gas. So we will observe effervescence. We'll observe effervescence, bubbles. So this is a test for the identification of the carboxylic acid groups. Now, phenol is also acidic, weakly acidic, but does not react with sodium bicarbonate like carboxylic acid. Why? The same reaction when we perform with phenol and sodium bicarbonate, the reaction will not take place, no reaction. Why? We know that phenol is weakly acidic, but you should know phenol is much weaker than carbonic acid. So therefore, this phenol will not react with sodium bicarbonate to give carbon dioxide gas. So hence the answer for this question is option 1. Phenol is weaker than carbonic acid, soda water. Carbonic acid is soda water. Since phenol is much weaker than carbonic acid, it does not react with sodium bicarbonate. Hence the answer for this is option 1. Phenol on treatment with dilute nitric acid at room temperature. Phenol on treatment with dilute nitric acid. So dilute nitric acid, concentrated nitric acid, you should remember. Phenol is ortho-para-directing groups. Since this ortho-para-directing groups, if it is allowed to react with nitric acid, what happened? Nitric acid, I can show an hydrogen atom at ortho position here. Nitric acid, we will write it as OH and NO2. So H and OH gets eliminated as water. In place of H, NO goes. Therefore, we get a benzene ring and you get NO2. This is ortho nitrophenol. Similarly, if I show the second molecule of phenol like this, second molecule, we show hydrogen at para position. So we'll take the second molecule of nitric acid here, OH and NO2. H and OH gets eliminated as water, the second molecule. In place of H, NO2 goes. So you get a benzene ring, OH, and you get what? NO2. So it is called as para-nitrophenol. So when phenol is treated or heated with dilute nitric acid, we get a mixture of orthonitrophenol and para-nitrophenol. Hence, the answer for this question is option 2. This is orthonitrophenol and this is para-nitrophenol. Followed?
Yes, sir.
Yeah. Now the next question: which one is the most acidic? Can you tell me which is most acidic here amongst all this? 19th question. Now we learned electron donating group destabilizes the phenate ion and decreases the acidic strength. Likewise, we also learned electron attracting group. Electron attracting group stabilizes. Yesterday I was teaching you this. Stabilizes the phenate ion. Stabilizes the phenate ion and increases the acidic strength. Now, if you observe phenol, this is the simplest phenol, and it's an electron donating group here. Since it's an electron donating group, it destabilizes the ring. So, para-methylphenol, that's option A, will be less stronger than option B. Right. Next is, this is electron donating group. These three are also electron withdrawing group. And there are 3 electron withdrawing groups. Since here we have 3 electron withdrawing groups, the phenate ion will be more stabilized and this will release H plus ions more easily. This will be more acidic in nature. The most acidic will be this. This is also acidic and this is most acidic. So the answer for this, the option will be A is less than B, B is less acidic than C, and C is less acidic than D, meaning D is the most acidic. D is most acidic. So therefore, the answer for this question is option D. So as the number of electron withdrawing group increases in the benzene ring or in the phenol, the acidic strength increases. Hence, the answer for this question is option D. The next question. Reaction of phenol with chloroform in the presence of dilute sodium hydroxide finally introduces which one of the functional group? You know this reaction. We spoke this reaction twice today. Please give me the answer. Let's see. What is the option? Reaction of phenol with chloroform in the presence of dilute sodium hydroxide finally introduces which one of the functional group? Take a chance and tell me whether it is CH2Cl, OOH, CHCl, or CHO. Can you identify what is the name of this reaction?
Sir, Raymond-Tiemann reaction.
So Raymond-Tiemann reaction. So what will be the final product? Phenol, chloroform, and sodium hydroxide. So the product is salicyl aldehyde. Yesterday we learned the mechanism, salicyl aldehyde. The product salicyl aldehyde will be this C6H5, OH, and CHO. This is the formula of salicyl aldehyde. So finally, the aldehyde group is introduced. Hence, the answer for this question is option 4, CHO. The next question. When benzene diazonium chloride is treated with water, the compound form is benzoic acid, phenol, benzene, aniline. So when benzene diazonium chloride is this C6H5, N2Cl. When this is hydrolyzed with water or reacted with water we can write it as H and OH. HCl gets eliminated. This N2 also gets eliminated as nitrogen gas. So what else is left out? You have a benzene ring and you have a OH group. So this is nothing but phenol. So when benzene diazonium chloride is treated with water, the product what we get is phenols. The next question. Preparation of phenol from cumene is reduction reaction, oxidation reaction, disproportionation reaction, ozonolysis. So cumine's process I have taught you in 3 steps in the previous classes. So you can just go through that reaction. So the preparation of phenol from cumene is an oxidation reaction because it happens only in the presence of oxygen or it happens in the presence of air. Therefore, it is an example for oxidation reaction. The next question, 23rd question. If chlorobenzene is treated with A, NaOH, and B, HCl, the final product formed is. So chlorobenzene is C6H5Cl. This chlorobenzene, when it is treated with NaOH, what happened? This H and Cl gets eliminated as HCl. In place of Cl, ONA goes. Therefore, we get a compound called as sodium phenate. This is intermediate compound and it is called as sodium phenate. This sodium phenate, when we acidify, treat it with HCl. HCl is B. So what happens? Na and Cl gets eliminated as NaCl. In place of Na, H goes. Therefore, the product what we get is phenol. The product what we get is phenol. Hence, the answer for this question is option B, phenol. Option 2, that is phenol. The next question. There are a few questions and then we are going to the topic ether. Which of the following statement is correct for the stability of ions of ethyl alcohol and phenol? Which of the following statement is correct? Ethyl alcohol and phenol. Delocalization of pi electrons in phenoxide ion, delocalization of electrons in ethoxide. This ethoxide alcohols are not stable because there is no stabilization. Inductive effect of ethyl and phenyl group, no. Delocalization of sigma electrons in phenoxide ion, no. Movement of pi electrons in phenoxide ion. Yesterday I was teaching you, in the previous classes I was teaching you the resonance structures of phenoxide ion. These electrons move to the carbon and oxygen gains positive charge, carbon 2 gain negative charge, all that we were discussing. That is nothing but delocalization of pi electrons in phenoxide ion. Hence the answer is option 1. The next question, the correct order, acidic order of the following. This is very simple. Tell me what will be the correct acidic order of the following. Which is more acidic? Which is least acidic? Which is more acidic? Which is least acidic? The strongest is nitro because this is electron withdrawing group. The weakest is this because this is also electron donating group. So strongest is option 3, nitrophenol. And next is phenol itself is stronger. And phenol is stronger than paramethyl phenol. So therefore, the order for this is option 2. 3, 1, 3, 2. The next question. The incorrect statement among the following. Ferric chloride is used to detection of phenol. Correct. Ferric chloride, neutral ferric chloride gives pink color. Failing solution is used in the detection of glucose. Failing solution A and B. In biology, at least you would have learned failing solution detection of glucose. Tollens reagent is used in the detection of unsaturation. Tollens reagent is used in the detection of ammonia. Therefore, this is wrong option. And sodium bisulfate is used in the detection of carbonyl compound. This also is true. So therefore, the incorrect statement among the following is the third option. Tollens reagent is used in the detection of unsaturation. Next question. Steam volatile isomer among the following is steam volatile isomer among the following: orthonitrophenol, paranitrophenol, both and none of the above. See, steam volatile. In case of orthonitrophenol, there is a bonding called as intramolecular bonding. Intramolecular hydrogen bonding. So bonding within the molecule. Now, if we take paranitrophenol, we can represent paranitrophenol like this. One more paranitrophenol I will represent like this. This is O and H like this. This is NO2. So there will be hydrogen bonding formed between two different molecules. This kind of hydrogen bonding is called as intermolecular hydrogen bonding. So here the boiling point of orthonitrophenol will be lesser than paranitrophenol. Why? Because in case of paranitrophenol, these bonds have to be broken. But here the bonding is within the molecule will vaporize as such. Therefore, the steam volatile isomer among the following is orthonitrophenol. Orthonitrophenol. The next question, the IUPAC name of the following compound is the IUPAC name of the following compound: cyclohexane ethanol, cyclohexane methanol, cyclohexyl ethanol, and cyclohexyl methanol. So this is CH2OH. So we have CH3OH, this is methanol. So if one of the hydrogen atom is replaced by a hexagon, that is cyclohexane. So this will be called as cyclohexyl methanol. The parent alcohol is methanol. Hence the answer for this question is option 4, cyclohexyl methanol. The next question, sorry, can you see the screen?
Yes, sir.
The next question, the IUPAC name of the molecule shown. What is the IUPAC name of this molecule? So it is, this is the functional group. So I write it as 1, 2, 3, 4, 5. Since we have 5 carbon atom, it will be called as, and it's in the form of a ring, cyclo. Since 5 carbon atom is spent, and a third position, the double bond starts, therefore 3 ene, 3 ene, pentene, cyclopentene. At first carbon atom, you have an alcohol, therefore 1 OL. So it will be called as cyclopent3ene, 1 ol. So the answer for this question is option 2, cyclopent3ene, 1 ol, option 2. The next question, 30th question. Phenol on reacting with chlorine in the presence of anhydrous aluminum chloride. Compound A is formed. This compound A treated with sodium hydroxide, phenol is formed. What is compound A? So this is benzene. When it is treated with chlorine in the presence of anhydrous aluminum chloride, H and Cl gets eliminated as HCl. In place of H, Cl goes. Therefore, we get a benzene ring, and you get what? See, this is chlorobenzene. This is chlorobenzene. This is A. This chlorobenzene, when it's treated with sodium hydroxide, Na and Cl gets eliminated as NaCl. In place of Cl, OH goes. Therefore, we get phenol. So the answer for this question is, they're asking what is A. So A is chlorobenzene, option 1. The next question. In call-based reaction, I taught you, in call-based reaction, the product formed will be, so phenol, sodium hydroxide, you get sodium phenate, passing carbon dioxide first and then acidifying. So the product formed is salicylic acid, salicylaldehyde. So it will be OH and you will have CHO here. So salicyl, no, sorry, not salicylaldehyde. It will be salicylic acid. Call-based reaction always gives salicylic acid. So this is not the second, right, third option. Not the third, the fourth option, orthosalicylic acid. This will be called as orthosalicylic acid. So this is called as call-based reaction. So many questions we have learned based on the topic phenols and alcohols. Now we are supposed to talk with respect to ethers. Just give me a moment in time.
Yes, sir.